Do your roots look like this? Do you pray to the welding gods that you chose the right profession and that this isn't as hard as it looks? Well, let me give you a couple tips on how to really fine tune this 6010 open root and quit blowing holes in your plate. Welcome back to the channel, everyone. You're gonna have to mind the noise. We're here at PWA where the instructors and the students are just getting after it, welding and grinding away so that they can be great welders one day. Now, Colin Techham asks Inside App, does anyone have some tips for running open root stick? I keep burning through and I need some advice. I've got several bits of advice and variables that you need to follow so that you can find that sweet spot for your 6010 open root. Now, one of the very first essential variables that we gotta go over to get these two pieces of plate stuck together is our gap. Now, I'm not talking about gapping your buddy on the highway with your race cars. I'm talking about the appropriately spaced gap in between these pieces of plate. And that's gonna vary depending on your rod size and the material thickness. The smaller the material, the probably smaller the gap. The smaller the rod, the smaller the gap. For example, you got a 1/8 electrode, you should probably max out about 1/8 of an inch gap so that it has enough room, but it's not too wide and it's gonna be going all the way through because the flux is a little bit bigger than 1/8 of an inch. So it won't actually go all the way through the gap. Now, too tight of a gap is gonna have a problem where you can't push that rod through enough to get onto the back side. With a big gap, you're trying to fill and fill and fill, and you just got a gnarly keyhole. With a too tight of a gap, you have no keyhole at all. And we've got to have some sort of a keyhole with this gap so that we can get complete joint penetration on that back side. Now, you can space this gap as whatever you'd like. It really does come down to preference until you get somewhere where they're gonna pretty much pick it for you. And sometimes you get good, sometimes you get bad. But you can go anywhere from 1/8 of an inch with an 1/8 inch electrode, 1/8 of an inch, 3/32 of an inch, a 16th, or even just a hair. You can use all these things and use the appropriate land to get that CJP. Now, class, can anyone tell me what CJP stands for? Rico. I don't know, carjacking procedure? No, see me after class. Jonathan. Well, since it's almost lunchtime, all I can think about is crispy jalapeno poppers. Just go to lunch. CJP stands for complete joint penetration. And to get complete joint penetration, we have to make the entire piece of metal all filled with rod or weld throughout. That's how you get complete joint penetration. Now, you can prep the plates with a double V groove or a single V groove or a bevel, doesn't matter, but there's different ways that you can go about it, welding on both sides, one side. And in this instance, we're running a single V groove and we're only welding from one side. So we have to have the right gap accompanied with the right land. Now, your land, or your root face to be technical, is just that little flat spot that you put on the edge of your bevel. If there's no flat spot that you ground on and it's just a fresh cut or a fresh factory, then you probably have no land. Or people will even grind it to where it's super sharp and they call it a knife edge. Now, these lands are what help hold in your heat or your amperage. Now, you want to accompany this with your gap. The wider the gap you have, the bigger of a land you need. If you have a wide gap and a very little land, you're gonna be eating that up. You're gonna have a keyhole. You have no freaking choice, and it's probably one of the hardest things to weld. Now, if you have a super heavy land and a really small gap, you're not gonna be able to get through that plate to get that complete joint penetration, or you just have a little skinny little slug, little snail running right through the middle of it, and that's not really a solid weld. So you wanna accompany your land to your gap. If the rule of thumb is real simple, keep it easy, same land, same gap size. Just keep them all the same. Now, my preference is gonna be that 3/32 land and 3/32 gap for most things 60-10, whether it be horizontal, vertical, overhead, or even on some pipe. Hey man, can you get me up a little? Oh, not like that, just up a little amp. Give me some more amps. Now, your amperage is gonna vary, and this really depends on a few things: the weld position, the size of rod that you're using, and the fit and prep. So if you have the right kind of fit up and the right prep, just like all the other ones that we had, no matter what land and gap, if you match them, you could just about run the same amperage. 85 amps might be able to get you through that just a hair, or that 16/16, or that 332 and 1/8 or 1/8. But if you start getting a bigger land and a tighter gap, you're gonna need more amps to get through it. The tighter the gap, more beans. The bigger the land, the more beans. But it is all subjective to whatever the fit is and the weld position and rod size. Now, just to be a little clear, if we have an 1/8 of an inch land on here and we start with an 1/8 of an inch gap, we might be at 85. But we keep that 1/8 inch land and we bring it down, we're gonna, to a 3/32, we're gonna need 90 amps or so. We bring it down to a 16th, but still have that 1/8 inch land, we're gonna need tons of beams to bust through that heavy land. And now we reverse it. If we have just start bringing our gap back open with no land, now our amperage is gonna have to start going down. So again, it all depends on how you decide you like your prep and your fit. Now the best way to describe the next variable, which is gonna be arc length, is by using this flashlight. Flashlight. Yeah. If you don't know already, your arc length is the distance to the land, to that gap and to that land. And with this open root, we want to be feeling our pressure. We want to feel pressure up against that. If we start backing away, the voltage on our machine actually increases and it makes things a lot hotter and we end up blowing big holes. So we got to maintain a tight arc length. We want to see all that fire coming out the back side. If we use this flashlight, we can really see that representation. If I stay close with that flashlight, that arc is confined to that spot. As I back away, that arc gets wider and my voltage increases, thus putting a big hole. We can run a longer arc length and close up a plate, but it's typically not gonna have the right stuff on the back side, and we're trying to get that CJP. So we wanna reach in and you physically wanna feel the pressure. You almost feel it so much, you should feel yourself pushing up against that plate, and you almost have to just go by feel and sound and much less visual, because you don't really see much at all except a little bit of a keyhole. Now the last bit of advice that I can probably give you, and it really just ties everything in to find that sweet spot, is being able to read and interpret your keyhole. A keyhole is that little bit of a hole that you carry in front of your weld, and sometimes it can get out of control and turns into a hole. You got to maintain that, but you have to maintain that by either changing your gap, your land, your arc length, or your amperage. These 4 things is what the keyhole will tell you to do. So if you see your keyhole really opening up wide, you need to put a heavier land. You need to tighten your gap. You need to turn down your amperage. You need to do one of these things, push your arc length in order to make that keyhole manageable again. If you don't see a keyhole at all and you're worried about getting that complete joint penetration, you need to turn things up as far as your amperage. You need to open up your gap. You need to make your land a little less or soft, or you need to maybe just pull back a little bit to get that voltage a little bit hotter and carry that keyhole and really open it up. That keyhole is your way of reading that you are getting that complete joint penetration by chewing up both sides of that bevel. You should be trying to like feed Pac-Man as you're coming through. Now, do you drag it or do you whip it? And that, again, that's gonna come to depending on your fit up and your gap. Usually the wider the gap and more struggle with that keyhole, the little bit of a whip we need to have to let that cool and stack on there where everything's getting nice and tight and where they like to be, then we can kind of motion towards a drag. I like to stay away from just straight dragging it. I like to have a little bit of a wiggle and carry a little bit of a keyhole and see it so I know that I'm tying in to both plates right here. I'm gonna do my favorite fit up, which is gonna be a 3/32 land, 3/32 gap. And we're gonna be running this about 80 to 85 amps, depending on what it does. If things start to close up, I might need to bump it up a hair. Oh yeah, carrying that little bit of a keyhole all the way across. I love to see it. We don't want to get too crazy with this 2G position because then it'll start to sag. I might favor the top bevel a little bit more because of that position. Always give it a little feathering to tie in. The pros may not have to do it, but you do. Do as I say, not as I do. Now our gap's getting a little tighter, so all we gotta do is just turn it up a little. Give me 5. Diving in, coming forward, stepping back, giving it a second to cool. You want a nice straight in rod angle. If you're leaning back too much, it's gonna be a little hotter. We're having to whip right now because that keyhole, which is okay. Now we're gonna try to just drag it, maintain that heat a little bit better into a nice little bit of a drag. And that's just from pushing in that arc length and letting that keyhole catch up to me. If I start to get pushed out like I see here, I might need to stop and turn up the machine. Now with our amps pumped up, we can have that keyhole we kind of had at the beginning, or the weld that we had towards the beginning, by just bumping up our heat. And this little clamp here on my left hand it's not cheating. Imagine it being a bigger section of metal. Just keeping everything nice and steady so we can maintain all these variables. That's how you get the sweet spot for your root. Now this is what the weld should look like before you do any cleaning. If you know that you wanted weld on the back side, you should have like a little bit of weld. All your roots should be sucked in there real tight. The only high spots you should have are the starts of your tie-ins where you started ahead and then fell off into that keyhole and kept going. But that's how you know you've maintained that arc length properly. And if it looks like that in the front, it likely will look something like that in the back. And then the weld is all on the back side. It almost looks like we welded on this side, but really we just push that rod through with the right gap, the right land, the right arc length, the right amperage, so that we can achieve complete joint penetration. Colin, I hope this helped you out. This will help better understand why you're blowing holes. So you need to make a bigger land. You need to tighten that gap. You need to turn down your amperage, or you need to push in your arc length. So remember, just relax. Welding is just welding, unless it's welding. See you on the next one, guys. Thanks for watching.